Welcome to week 3, where we will be discussing water cycling in the atmosphere, and specifically we're going to be talking about mostly humidity and dew point. So in this first video we're going to talk about how water behaves and how it's relevant to meteorology, and then in week 2 we're going to talk about in video 2, we'll talk about the hydrologic cycle and how it works in some more detail than the last few weeks. Then we'll get into what humidity is and dew point, how we measure them, and then we'll discuss how humidity and dew point vary over time and what causes those variations with time and location. So, behavior of water. Water can exist on the Earth's surface in 3 phases: solid, liquid, gas. Hopefully this is familiar from previous science classes you may have had years ago. And then as water changes phase from solid to liquid or solid to gas, it will gain or lose heat energy. So latent heat is the energy required to change a substance from one state to another. So that's what we call as heat. It's required to go back and forth. So we're going to do a little simulation in the next few slides here, but basically this is our 3 main phases of water and the process that each, as you transfer from one phase to another, the process by which that happens. So for example, melting, freezing, sublimation, and so on. And you can see when the arrows going, black arrows are going in the same direction as the blue arrows, we are going to be taking energy from the environment. And when it's the red arrows, the arrow down here at the bottom, we are releasing energy. So for example, if we condense water, so we go from the vapor to the liquid phase, we are releasing heat energy to the environment. Whereas if we were to melt ice, a solid, to a liquid, we're taking heat energy from the environment. And basically if we have more energy in that substance, like a vapor versus a liquid, we are going to see that warm liquid or air move faster than colder. And here in the next few slides you're going to see the symbol Mickey Mouse here where the large circle, the blue one, is oxygen, and then the 2 smaller, the red ones, are going to be hydrogen. So those bond together to form H2O, the molecule H2O. So these are different atoms. And so in our next few slides here you're going to see these little Mickey Mouse guys that are representing water molecules. So this simulation that we are going to do, I'm going to walk you through here. In this case we're going to start at the liquid phase in our little container. We've got a thermometer on one side, we've got the light gray is going to be the liquid. We're going to zoom in on that liquid or whatever's in this container to see what the molecules are doing. If we were to magnify it by quite a bit. And then I'm going to tell you what's happening. So is it evaporating, is it melting, so on and so forth, and how much energy is required or released in each of these simulations. So in our first simulation, we are going to take that liquid and we're going to freeze it. So we are going to go, as you see this bolder arrow, from the liquid phase to the solid phase. And what we see is this darker gray area is going to be representing the ice that's forming in this container, and then we still have a little bit of liquid in the center. So we're starting to freeze it. Eventually, if we keep this temperature low enough, we will freeze the entire container. And you can see our temperature is relatively low. And this is removing 80 calories per gram. So we're losing energy to the environment. This is happening at or below 0 degrees Celsius at sea level air pressure. So if you go up much higher in elevation, that's going to change. That's part of the reason why you have different baking instructions for different elevations. So we're removing 80 calories per gram from this system to freeze that water. So if we move to the next one and we melt that ice, you can see we've got our block of ice in the center. We're melting it from the outside. We're adding heat to this system. We're using 80 calories per gram to melt that water, so to break apart that structure that we formed previously. So this is happening at and above 0 degrees Celsius. So solid to liquid, we are requiring energy added to this system, and that's what this arrow indicates. So if we continue on and we go from the liquid to the vapor phase, we are boiling that water. So we are taking this water container, we're boiling, that's what these little circles mean, and then we are making those water molecules go into the vapor form in the top of this container. So we're losing our water molecules from this bottom here. We're evaporating them into the air. And you can see our temperature is much higher. So boiling happens at and above 100 degrees Celsius, and it requires the adding of 540 calories per gram of heat energy. So a lot, way more than it takes to melt ice into the liquid form. So if we go from the vapor to liquid phase, we start to condense water, and that's what these little gray blobs are supposed to represent, water condensing on this glass of this jar here, and then dripping down into the container. So we're adding those water molecules back into this beaker, and we are removing 540 calories per gram from this system. So the same amount of energy that's required to vaporize that water is going to be required to put it back into the liquid form. And this happens at and below 100 degrees Celsius. So again, we're removing heat from this system. So if we go from the solid form to the vapor form, this is called sublimation, and this happens in the wintertime. It happens on glaciers where you go from straight solid ice to the vapor form. It might happen in your freezer as well. You might notice if you look in there, you put some ice cubes in the freezer and you let them sit there for a while, you don't use them, and you notice you go to use them a couple months later and they're way smaller than they used to be. That's because you have sublimation happening in your freezer. You have solid ice that is skipping this liquid phase and going straight to the vapor phase. And this requires 720 calories per gram. So a lot of energy needs to be available to change from the solid to the vapor form. And then if we go the opposite way, we go from vapor to solid. So frost is an example of this, taking water vapor out of the air and then depositing it on grass and plants and whatnot, or your car windshield. This is called deposition, and it requires removing 720 calories per gram from that environment to actually form a little layer of ice on the top of this this jar here. So this is the way water and energy relate to each other. So again, when we're moving to the right in this flow chart, we are adding heat to the system. When we're going the opposite way here to the left, we are removing heat from the system. So that wraps up how water behaves and how it's relevant to meteorology. We're going to transfer that now into the hydrologic cycle in the next video.